Lesson 1.8, Rates, Ratios, and Proportions. Rates, ratios, and especially proportions are very important. They get used a lot, not only in algebra, but also in other areas of math. A lot of word problems or logic problems can be solved using proportions or ratios. Okay, we have a lot of vocabulary with this lesson, and much of it you'll be familiar with, but it's important that you understand the differences between them in order to use proportions and ratios effectively. So a ratio is just a comparison of two quantities using division. So I could say that I have 2 quarters for every 5 dimes that I have. I can also write it as 2:5. Either way is fine. It's basically just a way of comparing them. Proportion is just going to take one ratio. Okay, I have 2 quarters for every 5 dimes. All right, and I know I have, so there's my 2 quarters for every 5 dimes, and I know that in my change jar I have 30 quarters. How many dimes do I have? And that's going to be your proportion. Okay, that's going to be what you will figure out. All right. A rate is just going to be a ratio with different units. Okay, so quarters and dimes works. Also, the more common ones are going to be miles per hour or feet per second, some distance and time unit, or volume and time unit. Time is definitely the most common in a unit rate. And we use those to figure out generally over a certain length of time or a certain area, what is the second value going to be? What's your other value? Okay. In a unit rate, it's the same where you're having different units, but now we're making sure that our second quantity, our denominator, is always 1. Okay, so miles per hour, it's always 1 hour. Okay, feet per second, always 1 second. So we make sure that we have those in terms of 1 because they're most easy to evaluate that way. If I know I'm going 30 miles per hour, it's easy for me to say, okay, I drove for 4 hours. How far did I go? 130 miles or 120 miles, right? If I had miles per 2 hours, then all my math gets just a little more complicated. Dimensional analysis is just a process that uses rates to convert measurements to a different unit. You can think of those as gallons to liters, or Celsius to Fahrenheit, inches to millimeters, centimeters to millimeters. You're just going to be converting measurements. Okay. When you're using proportions, we use what's called cross products. Okay. And if we go back up to our 2 quarters for every 5 dimes, and I have 30 quarters for how many dimes? To do a cross product, you're going to take the numerator of each and multiply it by the denominator of the opposite ratio. Okay, so in this case I'd end up with 2d equals 5 times 30. That's going to be my cross products. And then from there, if I'm going to solve, I would just divide by whatever is next to my variable. All right. And then the scale. A scale is something that we should all be familiar with. If you think on a map, if you have little 5 inches equals 10 miles or something like that, we'll often get a little scale that looks like this, and it might look like this, and it's like each one of these hash marks is a mile, right? So it's just a ratio between 2 measurements where you're keeping something to scale. All right. Our first concept is using ratios. Okay. If I'm using ratios, I am probably setting something up into a proportion. So I am going to try and solve for another value. Here, my ratio is in this first sentence. There are 2 girls for every 3 boys. So if I have 2 girls for every 3 boys, if there are 18 girls, so this is a proportion, I'm going to keep it equal. If there's 18 girls, how many boys are there? All right, so I start off writing my ratio. I add in the given information and the variable that I'm trying to find the value of, and then I can cross multiply. And I end up with 2b equals 18 times 3, divide by 2, divide by 2, and b equals, let's see, 18 divided by 2 is going to be 9. 9 times 3 is 27. 27 boys. All right. One of the really cool things about ratios and proportions is that you can write them in a number of different ways. Okay, so I have 2 girls for every 3 boys is equal to 18 girls over 27 boys. Right? That's what we just figured out. Okay. But I could also say that 2 in my ratio, these 2 girls, out of 18 total girls in the class is going to be equal to 3 in my ratio of boys to 27 in the total class. Okay, that's also going to be a proportion, and I could just as easily have used this to solve my for the number of boys as I could this. All right. You can also flip things around. So I could say that I have 3 boys for every 2 girls, and that is going to be equal to the number of boys over the total number of girls. Okay? One of the main reasons why we want to think about writing this in different ways is we can save ourselves some steps when solving a problem. So if we go back up to this problem, where I had 2 girls for every 3 boys, and that's 18 girls over boys. Okay, I had to cross multiply, and then I had to divide whatever was next to my variable. But if I had set it up as 3 boys over 2 girls, equaling the number of total boys over 18 girls, now, in order to isolate my variable, all I have to do is multiply by 18, multiply 3 halves by 18, and that's going to give me the answer, and that's going to save me a lot of steps. Okay, so if possible, and sometimes it's not possible, but most of the time, if you think about how you're setting up your proportion, you can do it this way. Try to make sure that your variable is in the numerator position, because that'll save you time when solving the problem.